Hello everyone, good evening. Good evening and welcome to day 3 of our AI with NVIDIA Masterclass. Good evening all, am I audible? Can you guys see my screen? Welcome to day 3 session. Good evening all, can I get some response? Yeah, good evening and welcome to day 3 of AI with NVIDIA. I hope I am audible and I hope you guys can see my screen, right? Good evening all. So in this particular day we are going to discuss about particularly the CUDA, memory hierarchy, CUDA for deep learning and all. So today we will be also going through some of the demos which is available in your Jetson. These are some of the demos which shows you for example, the utilization of CUDA, what is the use or what all things you can achieve, especially with the particular Jetson Nano will be discussed here. And as you guys know, in our previous session itself, we have directly connected to our Jetson, right? So this is the headless mode. Actually, I am having my particular Jetson connected in both the ways. So it is also headless mode as well as I have connected the monitor, keyboard and all. So whatever I do here, okay, so it will be reflected in my laptop screen so that you guys can see it as well. Okay, so can we guys start today's session? I hope we have left in between in the previous session. Actually, is my audio clear, guys? Can I get some response? Am I audible? Is everything fine? Good evening. Is my voice clear? Can I get more response in chat box? Okay, so especially we have seen finally about the Jetson stats, I hope so, right? So let us go back before going into this one. We were discussing about this Jetson stats and we have rebooted it, but when I used JTOP we actually had an issue. Actually that particular problem was repetitively coming, it was not solving in yesterday's session. Okay, so what we done after that is we tried to sort it down and finally we got a result where we just want to reinstall with no cache directory. So this is the command sudo -h pip3 install no cache directory -u Jetson stats. It will be installing from the scratch again. Okay, so once it is done, okay, you could go and use this JTOP to actually see. So let me just do it. Let me just show you guys what will be done. So that Jetson stats you could access it via JTOP. Okay, so if you run JTOP you would be getting a screen something like this. So this gives you some of the details. For example, it could be something like what is your Jetpack version. At the top itself you can see all the configurations you have in this particular Jetson Nano. The Jetpack is 4.6.1. So here the second panel is for the GPU information. So this is the integrated GPU, this is the share the RAM. So it has 4 GB the RAM, so whatever GPU is occupying, and this is the percent of current usage of your GPU. So when you run complex models, you would be getting some more usage here. You see it goes to 100% and all. So you look at CPU, you have 4 core here. So all the 4 cores are now in medium. If you use or run any particular process, it is going to jump to 100%. So this is the memory usage. So out of 4 GB RAM, currently 1.3 has been occupied, and this is other details. Okay, then you have the control. Then finally in info you can see the CUDA version, the CUDA for deep learning version, the TensorRT version, the OpenCV version. With actually CUDA is not available for OpenCV. We will be later on. We will be discussing about how to install here and make it yes. And apart from that, your Jetson informations and all available. What is your LAN, IP addresses and all. This IP is what I have connected now. Okay, I hope you guys are clear the usage. So you could press exit to come out of it. So that is JTOP. That's what we have discussed at last in the yesterday's session. So going into the next content, actually, we are going to discuss about NVCC. So this NVCC is something, a command which you could use. So what is this NVCC is? It is NVIDIA's CUDA compiler driver. Okay, so it is a driver which is going to help you, for example, which is used to compile the CUDA code. So CUDA is something like a program by NVIDIA for efficient usage of GPU. So we'll be later on discussing about the particular information and all about CUDA. So NVCC can compile CUDA code written in C, C++ or Fortran. That includes extensions allowing you to write functions to be executed on the GPU, and it includes global, device, host, keywords and all. So you could check the NVCC version with NVCC double hyphen version. So if you run this, you should get the NVIDIA version. Okay. But the problem is sometimes it will be recognizing and sometimes it may not. Actually, NVCC comes pre-installed in your Jetson, but your Jetson Nano may not be aware of its location. In such case, we have to add the path manually, okay, by using the following commands. Okay, so you have to use gedit, which is something like a notepad. Here you have to open this bash or C. So let me just repeat these paths, and you guys please follow through me what I am doing. Okay, so I hope I could go hands-on in this. So let me just go and switch my slides back into our Jetson Nano headless mode. So let me just show, please wait a minute. So here we are. So what I'm going to do now is I'm going to search for sudo superuser, use gedit, and edit the file which is present in the home directory, which is going to be bash rc. Okay. So if you run it, you will be getting a notepad getting open with some of the commands inside of it. You need to enter your password. So it will open something like this. Okay. So here I just want to add 2 lines which I have shown in the particular slide. For example, in my slides I have shown you, right? So this is the command for opening. These 2 you want to add. You want to write these commands, and what this command is, this is the location or the path of your CUDA. Okay. So where CUDA will be installed, it's inside user local CUDA bin. You would be having it, and you want to just have it here. You want to just add this path, and you have to save it. So for saving, you have to go with source and this file name exactly. So now let me add these 2 lines there. Let me show you guys lively what I'm going to do here. So let me just add this particular line. For example, export path is equal to a variable which is going to be the path, and let me add the path here. So it is going to be user local CUDA and bin. Okay, so this is the location especially. Then export. Okay, so LD library path is equal to let us go local CUDA, then inside library 64 you have it. Okay, so this is what the location. Please we'll check it once again so that it will be error free. So we have given the location, so just I need to go in the top right and save it. So once you saved it, you can just close it and you have to go for the next command, which is going to be, so now it has been set it successfully. Are we clear with the steps? What we have done is pretty much simple. Okay, we have just opened and edited this particular file. Can I get some response in chat box? And we are getting this NVCC, so this is mandatory. You have to set the location and you have to verify it, okay? Because later on when you try to execute your codes and all, there would be lot of problems coming you if you don't have this particular path set it. So it is better to go with this NVCC version. I think you guys need some of the demos, okay? So now as you can see, we have went with the NVCC version and it worked really well. And there are some demos which you could do. For example, there is something known as deep stream. Okay, so deep stream you have to install and you could go, it's like a package from Python. You could install and use it. Okay, it is something like which has been predefined. You could just run it. So deep stream is a streaming analytics toolkit. Okay, so it enables developers to create video analytics like object detection, classification and tracking and all. So this is the commands. Actually I have executed this, so you guys can just go and write sudo apt get install deepstream 6.0. so this is the version which is compatible. So if you run this, the deepstream would be installed. Once it has been installed, what you could do is you could check the version by going with deepstream app --version. So let us check. For example, let us go back here. Okay, I think this connection is cut off. Let us connect it again. Real VNC viewer. Okay, it seems like some issues with the connection. Let me just check the IF config and anything changed. 192.168.0.108. It's actually the same. Yes, I think now we are back online and my screen is being showing to you. Fine. So let me just go and type. Actually, where do we left? Can you guys pick it up? Because out of this trouble, I just forgot. Okay, so we have to check for the version, right? Which is going to be deepstream. It is deepstream-app version. Okay, deepstream-app _version. So if you check it, if you have it, you will be getting this particular version available. So once it is ready, you can go and execute your particular code or the example. So actually this deep stream would be installed in a location which is pretty much long actually. So you can see it will be inside of this OPT, NVIDIA, then deep stream 6.0, sources, apps. So you can go inside of this actually. So let me just go back inside of that particular directory. So I'll change it to option. So you could see all these things. You have to go inside NVIDIA here, CD to change the directory. So here out of this I have to go into the deep stream, you can see. And inside of that I have to go for deep stream 6.2 actually. Then inside of that I have to particularly go for sources. Okay. So I'll change the directory into sources, and after that we have to go inside of apps. I'll do it together. Then inside of that I have to go inside sample apps, and then if you go and check, you will be having all these sample apps available. So let me just go into test 1 actually. So, okay, so deep stream test 1. So it is a object detection. So I'll change the directory into deep stream test 1, and you have all these files. Okay, so now comes the next part. So we are inside of that particular directory as given here. So once you are inside of that, you have to actually edit the make file. I have done it earlier, but I'll show you how to do. If you try to run it, actually it won't run because it haven't mentioned the CUDA version, so it's optional. So you have to edit using your editor sudo vim make file. You have to edit the CUDA version as 10.2, then you have to make it. So you have to run sudo make, which will update this make file. So once it is done, this is the command. This is the command to we are debugging 3, and this is the command to run that app. And here is the pathway or directory of a sample video. Okay, it's a H264 video which I am going to take and I am going to run now. So for doing this, let us go and first edit, which I have already done, but I'll show you guys. So you can see there is something known as a make file available. Okay, so I'll go with sudo vim edit this make file. So you could see I have entered this CUDA version equal to 10.2, but initially it won't be there. It will be CUDA version question mark. So I added 10.2 and then I have to write and quit, and I have to run the make command. Okay, so when I run this make, the update will be done. So once it is done, I can go and run this particular thing. So I'll run with sudo gst debug is equal to 3. Then I'll run this particular app, which is going to be deepstream test1 app. Okay, so at the directory for my video, or where my if you have other video as well, you could also take that. So I'm going to use some of the video which is available in their example. So it is actually inside this directory, inside samples, inside of that streams actually, and inside of that I'll go with a sample 720p dot H264. So let me run this. What it does is it takes a model. It will be taking few, actually 1 or 2 minutes. It is going to compile. It will be transforming your model into another version, which is called as something known as the TensorRT format, which is a version which will be using CUDA very efficiently. Okay. So it has to compile. Please wait so that we could see the result. So these are demos. Actually, we are seeing demo. Next, we will see about CUDA and all. Guys, in the meantime, let it run actually. So in the meantime, if you want, you could convert this masterclass into 1 month certified internship on NVIDIA with AI. So when you join, you will be getting 30 days of recorded sessions, 30 days of PPTs, 10 exclusive projects, VIP community group, IETE letter, access, weekly live sessions, internship participation certificate, resume building, mock tests and all. You could get all these things at a discounted fee at 999. The link will be posted in chat box, and see here guys, the particular rendering has been done. As you could see, the video has been running, and this is what it is detecting. It is actually detecting the person, car and all, object detection model. And if you look at the terminal, you will be getting how many number of objects has been detected, person count and all. The same thing if you run it in Orin version and all, which is higher hardware, it will be run smoothly. Here also I am sharing my screen, so it is showing you like frame by frame, but it would be running better in my particular system here in the original monitor which it has. Okay, so this is one demo. You could use other videos or test one. This is, you could use other tests. Make sure that you edit the make file and then you do it. Okay, by adding the CUDA version. So I'll just close it off, this deep stream. So this is one demo with deep stream which you can particularly do. And coming back here, we will be seeing other demo which will be quite great than this. And before that, you can convert this masterclass into 1 month certified internship on NVIDIA with AI. and you will be getting 30 days of recorded sessions, 30 days of PPT, datasets, code files, downloadables, 10 exclusive project codes, VIP community group for doubts and internship updates, IETE confirmation letter, 90 days of LMS access course, assignments and tasks, weekly live sessions in Zoom where you can directly interact with the mentor and clarify all your doubts, resume building, mock tests, internship and participation certificates will be available for you. You could learn one step ahead. You could get benefited by getting certificate on NVIDIA with AI. The regular fee is 1,999 and the discounted fee is just 999. The registration link is posted in chat box and the internship ends on 20th. Okay, only 2 days is left. So today is 18th. Tomorrow will be the one more day will be available. So if you guys are interested, please make use of the link which has been posted in chat box. So that is deep stream. So there are other samples, for example NVIDIA Jetson. Okay, if lectures are 21, for YouTube free we are giving 21 days free, and for internship users it's a 1 month, so you get additional 9-day content. Okay, so that is what the 30 days is. Totally it will be 30-day sessions additionally for the internship users. The internship only stands for just 2 days. If you guys are interested, you could get certified. So the Jetson provides some samples, Vision Work provides some samples. Let us see. So you have to change your directory to this user local CUDA, and then you have to copy and use this particular thing. For example, let me just show you guys. This actually takes nearly 20 minutes. First, let me just go back into the user. Okay, so let me just share my screen as well for you guys. So let me go back into user, local, CUDA, and inside of CUDA you have all these things. I'm going to go into bin. Okay, and if you look at bin, you have the installation, which is the CUDA sample install. Okay, 10.2, you can see, right? Install samples. You have to copy it. Okay, so for copying you can run this particular command. You can just tell it, okay, dot hyphen, then run this command CUDA install, run this file, but you have to tell a path where to install. Add tilde symbol like this, and this tilde symbol will make it install in the home directory. So after running this, I have run it. If you change your directory by using this tilde symbol, you will be taken back into home. And if you look at ls, you will be getting this particular file, which is the NVIDIA CUDA 10.2 sample. So let me change my directory into that folder, NVIDIA samples, ls. You could see all these things, and also you have a make file. Okay, so make file means you have to make installation, so you can go and write make and use -J4. Okay, which tells that use all the 4 core CPU. Okay, so when I'm not going to run it, when you run it, it is going to take nearly 20 minutes of installation. I have already done. So once you install, you will be getting additional files like this bin, common, and all are extra files. So once the installation is done, okay, so you could go back into bin folder now and look at ls. You have to go inside of this ARC64. You can go inside of this Linux, okay, and you can go inside of this release, and it has some demos. For example, so you have all these demos. Okay, so let us see one demo. For example, Ocean FFT. There is something known as Ocean FFT. This is from NVIDIA. Okay, so this is a simulation of ocean. As you could see, these are some of the demos which uses our CUDA and NVIDIA. So you could see, right, it's actually in my original screen it was running really great. For you guys, since I am sharing the screen, it is taking pixel by pixel. For example, I'll just show you guys with the camera. Okay, here's our Jetson, and here's my screen, and as you could see, it is pretty much smooth whatever I am doing. So when I share my screen, it is not that much really great, and you guys could see, right? So I could zoom in, zoom out. So this is one of the demo. Okay, so let us see some more demos which you could make. For example, let me just close this off, and there are a few more things. Out of this, you could run any one, and you would be getting some nice results. Okay, there is something known as particles. Let us do it. Particles. So this is the particle, so it will be deployed, and you would be able to see the results. For example, how it is colliding and all. So you could add, for example, add a sphere, so a sphere will be dropping now. Okay, so you could get all these results by this. Okay, so apart from these, there are something which is more available, which is known as the examples in VisionWorks is also available for you. It is inside of this user, share, VisionWorks, sources, bin, release. If you go, you have other things. For example, let me show you, that will be really interesting with the help of CUDA usage and all. For example, let us go back into user, share, VisionWorks, sources, bin, arc64, Linux, release, and if I go with ls, I have all these demos. Let me just run, okay, the NVX demo for who transform line. Okay, so it will be opening a video like this. So as you could see, this line is the whole line, which is going to be majorly used for detection of lane and all. You can press M to switch into edges, and you could see this, and I think it will be rendering very bad. I think I could go and show you guys in camera itself. Okay, so it is smooth. If I press M, it is going to show or change it into the canny mode, where it detect the edges. It can be used to detect the center median and travel through it. Okay, so this is video. I could switch back by pressing just M. So this is a demo, and you could see it is running pretty much smoothly, right? So you guys want to see how much it is taking. Okay, so I'll just close this off, and for example, let me just switch back here. And when this demo runs, let me open a new terminal and use JTOG to show you guys how GPU has been utilized. So you could go for JTOG, and as you guys know, how much GPU and CPU has been currently consumed will be shown here, right? Okay, so let me switch into GPU. As you guys see, GPU is currently being used, nearly more than 80% it is going and coming, right? So if you look at CPU usage, everything is above 75 and all. So this is a demo. There are other demos available. Okay, you could go and look into it. Apart from these, we will be now going into CUDA now. So let us see one more demo, which is going to be feature tracker. So in this particular thing, it is tracking all the features which you could use for automations and all. This is a command. Then you could also go for I'll run this object estimation code. Okay, so it will be able to help you to detect the cars and all. So all these things are run with CUDA, and it utilize a lot of particular the hardwares, and that's why we use this. So what is this CUDA now? We are going to see now. Okay, so can we start with CUDA? Is the results from CUDA, is it great? Can I get some response in chat box? Are we good to continue with CUDA now? So CUDA, which stands for Compute Unified Device Architecture. Okay, Compute Unified Device Architecture. It is a parallel computing platform. Actually, your CPU performs tasks sequentially, one by one. But this CUDA has been something like which is prepared to run your code parallelly, or whatever task you are doing, you want to do it parallelly. It is primarily used to harness the power of NVIDIA graphics. Okay, for general purpose computing tasks beyond just rendering graphics. So it has actually, CUDA has been a program which has been introduced by NVIDIA. They have designed to use their GPU in a much more complex applications for data handling, for data scientists, machine learning engineers, deep learning engineers and all. Okay, and CUDA enables developers to accelerate various applications by taking advantage of the parallel processing. Actually, when you look at the CPU, the traditional CPU or your central processing unit is the brain of your computer, which does all the tasks, and they are designed to handle a variety of tasks, but they excel at executing tasks sequentially. flow of program. One by one it will be executed, and it is time consuming. As you guys seen, on day one I have shown you the drawing of that emoji, right? So it will be drawing one by one, step by step. And the problem is it takes a lot of time. You can go for GPU. So GPU initially were designed for gaming. Okay. So GPU were initially developed to process the graphics related calculations like rendering image. I hope you guys know. Okay, rendering means configuring and showing you guys. Actually, the screen you see is actually pixels one by one, top to bottom. It will be pixels of rows and columns matrix. Okay, so this pixels actually, if you guys played some high-end games like RDR2 or GTA 5, if you don't have GPU, you can't run it. Your quality will be very low because the pixels will be very low. If you want to have high amount of pixels, the clarity will be high, but which means it has to calculate a lot of numerical values. Okay, so it is going to calculate millions of values, and for that you need GPU. So GPU were initially used to render these images, which involve performing same computation but on massive amount of data points or pixels simultaneously. So this process, okay, this parallel nature makes GPU highly suitable for tasks that can be broken down into smaller, simpler computations that can be executed at same time. So this GPU was initially to configure and render high pixel values so that the clarity will be good, so you could play high-end games in your screen. Okay, so that's what GPU does. Later on, with the help of CUDA, okay, so this parallel nature makes it suitable for various tasks to be executed. Okay. Yes, you can go for VirtualBox, or you could also go for cloud-based. If you have access to AWS or Azure, you can go for virtual machines, create Ubuntu Linux, try to execute or repeat whatever we are doing. So this parallel nature makes it to process. Okay. So there is something known as GPU parallelism and CUDA cores. So modern GPU consists of thousands of small processing units called as CUDA cores. All these things can subdivide the task, do it parallelly so that tasks can be done very faster. So these CUDA cores work together in parallel, making GPUs highly effective for tasks that can be divided into smaller independent operations. And CUDA essentially opens up the immense computational power of GPUs for non-graphical tasks as well. So 2007 CUDA was released by NVIDIA. Later on, it has been used in your laptop, PC, supercomputers for handling huge amount of data, and all the data scientists, AI engineers are using this CUDA now for developing huge and AI algorithms. So it provides a programming model and a set of tools that allow developers to write code that can be executed on GPU. So GPU has memory, which is, or we call it as video random access memory, VRAM, which is used to store graphical data and computations. It can help render graphics, handle textures, and store frame buffers. With its processing power, GPU works to produce visuals. And data storage, speed, data access, texture mapping, memory type, bandwidth are also affecting the performance. So there is two types of memory. You have a dedicated and shared, so which is used, they have their advantage. So how does CUDA works? I hope you guys understand. CUDA is Compute Unified Device Architecture. It has a lot of cores. It is a programming which is going to help to utilize your GPU by splitting the tasks, and it is going to improve the performance by doing the tasks parallelly, where that your CPU does it sequentially. I hope it is clear. Okay, so how CUDA works, how it is achieving this faster, how it is splitting the task and working, that is done by three things. One is parallel processing, another one is threads and blocks, another one is SIMD architecture. So parallel processing, so the CUDA enables you to divide your computational tasks into smaller parts which can be executed concurrently on different GPU cores. So your GPU has multiple cores, ours has 128 core. So it splits, and all these things, your CPU, you can't run GPU without CPU. CPU is something like who is going to tell the instruction of what to be done. If you have GPU, CPU will be splitting the task and giving it to the GPU. So the GPU will be doing the task and giving back the result. Okay. So the CUDA enables you to divide your computational tasks into smaller parts, so the GPU cores can execute and finally give you a result. And this massively speeds up calculations compared to running the same task sequential on a GPU. So when we go for deep learning and all, tomorrow we start with deep learning basics. Then you can understand on that we will be doing something like for every training you are going to handle huge amount of data, million of calculations should be done, and that can be done in GPU faster with the help of CUDA, with parallel processing, then threads and blocks. In CUDA, computations are divided into threads, okay, and organized into block, one by one block. So they will complete and then simultaneously they give it back. And they can run multiple cores, then only they can run in parallel. And there is something known as SIMD architecture, which is called as single instruction multiple data, okay. GPU uses single instruction multiple data, which means a single instruction can be executed on a multiple data element. For example, a single operation can be performed on a batch of numbers at once, which accelerates the numerical computations. Okay, so the CUDA has a programming model which involves writing both the host code and the device code. Device is going to be your GPU, host is your CPU. Okay, so you have to run both the code. So the CPU or the host code, what it does is, the host code manages data transfer from your CPU and GPU, while the device code, your GPU, actually that code will perform the calculation on the GPU. And the host code executed on the CPU and manages GPU resource. Device code runs in parallel on the GPU cores. So the memory hierarchy is, GPU have different types of, it is simple, okay. GPU runs parallelly. It can execute multiple tasks parallelly. CPU executes sequentially. So sequential means one by one it will be completing, time consuming, but parallelly means 10 tasks done together, it can be done so. So the CUDA provides mechanism for managing data in different memory spaces. It includes global memory, shared memory, local memory, and constant and texture memory as well. So for creating a CUDA demo, we'll do a demo now. You could go and use this particular command. So let me explain. So you could install this build essential for running the CUDA codes and all. So once it is installed, we have to create a file known as vector add or any file. Okay, so I had with the extension of .cu, and then inside of that we have to write the code. I have it in my system, I will be writing it. So once you write that, it is a code to show you a demo of CPU versus GPU, how much time it has been taken for a task. It's a vector addition code. Once it has been done using our NVCC, remember NVCC is the CUDA compiler, so you have to compile this code using NVCC. You can run this file name and you are compiling in the name of vector add. So once it has been compiled, you will be running like this particular file, like we ran other commands, we will be running and we will be executing that code. So let us do it. And before doing that, you can convert this masterclass into 1 month certified internship on NVIDIA with AI. If you join the internship, you will be getting a lot of benefits, and it includes 30 days of recording sessions, 30 days of PPTs, 10 exclusive project codes, VIP community group, IETE internship confirmation letter, 90 days of LMS course access, assignments and tasks, weekly live sessions, resume building and mock tests, internship and participation certificates. All these things you could get it at a discounted fee at 999. The registration fee original is 1999. The discounted fee is just 999. If you guys are interested, the registration link is posted in chat box, pinned in chat box, and available in description. You could get and make use of it. And the internship ends on just 2 days. Saturday is going to be the last date. 20th will be the last date. If you guys are interested, you could register and get the benefits. So let us integrate this and execute and see this CUDA demo actually. So let me switch it back into our code here. So let me open the terminal which I have closed. I'll check for ls. As you could see, I don't have any file in that name. Okay, so the first step is you can run this particular command. I have already ran it, so you have to run the first two commands to install the build tools and all. So once the build tools is available, Okay, build essential. You could go and use virtual editor, okay, to create a file. For example, I'll go with a file name of vector add.cu. So it would be opening. So I could add I to insert the code. So let us write the C++ code. I have the code here, and let me write and explain it to you guys. So this is the code. It's a C++ code. I'll copy it and I will be pasting it in this particular terminal which I have opened. I am in insert mode, so I'll just paste it. So what does this code will do it? Okay, so we have the documentation and all. So it actually uses create a structure of x and y. So it performs complex vector addition one by one. So okay, it is going to add and store, and it is done on both CPU and GPU. So we are doing first on CPU, then we are allocating memory on the host. Okay, and we are initializing. So this is the command CUDA allocate. Okay, if you know C++, you can understand. Okay, so you are adding it to your GPU memory, okay, like you add it in your stack. Okay, we are doing in this. So we are starting a timer as well for our CPU and GPU to finally display how much time it has been taken on both CPU and GPU. Once it has been done, we have to free the memory, so we are deleting that as well finally. So this is the code. I have to press escape and use colon, write and quit WQ. This code may not be important for us because just it's a demo of how much it is taking. Okay, so now if I want to run it using our CUDA, so I have to configure with our NVCC, which is the compiler. So I have to compile this. So I have to go for NVCC -o, okay, create a file in the name vector underscore add, and what I am going to compile, I have to compile the vector add.cu. So when I run this, the code will be compiled into an app something like this, which we are going to get now. Yeah, so if you look at ls, you will be getting this green color, which is a CUDA file which you could execute. The vector add which I have asked is being now available. This is the name which I have given. So I could run it by calling full stop / the file name, which is going to be vector add, and when I run it, it performs the calculation, and you could see it is a faster task. As you could see, the CPU time taken for doing that task is 0.03. Okay, and the GPU is 0.01. It is doing pretty much faster. Okay, so it will be taking very less time. When you go for high-end calculations, it will be using further more and doing the task pretty much faster. So that is how we will be using CUDA. So this is just a demo. We won't write the C++ code and all. When we go for deep learning, there is a particular CUDNN available. I hope you guys remember this particularly. For example, when I went into the terminal and written the NVCC, the JTOG, we would be seeing some of the configurations. We have CUDA as well as we have something known as CUDNN version and all. So this CUDNN is nothing but CUDA for deep learning neural network. So what is deep learning, we will be learning tomorrow. So CUDNN is CUDA for deep learning application. It is a GPU accelerated library developed by NVIDIA for deep learning, and it provides highly optimized implementations of standard routines. Okay, such as if you guys know deep learning, you could understand. Otherwise, tomorrow we'll be learning what is this forward, back, convolution operation, pooling, normalization, activation layers and all. So this CUDNN is designed to work seamlessly with various popular deep learning frameworks like TensorFlow, PyTorch, Caffe and other one. So it has applications in video recognition, rendering, NLP, reinforcement learning tasks, and our famous, what all we see in our courses, TensorRT, PyTorch and TensorFlow and all these other libraries as well, they are configured with CUDNN. So if you use their library, you could integrate this CUDA, so you could train your model high complex mathematical calculations for your deep learning with the GPU and CUDA which is available in your Jetson Nano. So that is the use, and we will be going with these libraries to directly call our GPU without writing the mandatory code which you have run earlier. So you can manually write in CPU. You can write in C++ and execute manually, or it has been already pre-written in these libraries for deep learning purpose. We will be using it. So are we clear with this till now? Can I get some response? I think the attendance link is available. Those guys came for attendance can get, and you could fill the attendance. And particularly in tomorrow's session, we will be going with a concept which is deep learning basics. Okay, so if you want to learn deep learning, you should be familiar with the basics of machine learning. So if you have the knowledge, please go and refer to machine learning, be ready for deep learning. If you are a beginner, then I would just give you a refresh of what is machine learning. Machine learning, what we do, we create algorithms and statistical models which are capable of informed choices or decisions by processing data and learning from it. Whatever past has been done, you learned and analyze, give it to a statistical model. It learns what has been done in the past, it is going to repeat and try to give you an answer. Okay, so when we look at types of machine learning, we have supervised learning. For example, if I have a set of data which has all the features like this, and I have a label of this is circle, this is square, and this is triangle, I could train a statistical model so that later on when I give a new shape like this, it will predict whether it is a circle or a square or a triangle. So this supervised learning has two types. One is regression, another one is classification. Especially if you are predicting what is the temperature going to be tomorrow, like 84 or 84.2 or 83, or a value which is continuous, then that is regression. If you are going to predict tomorrow is cold or hot, it's a binary, so it's a classification problem. Here it is a multi-class classification. It's a classification between circle or square or a triangle. And this is unsupervised learning where you don't have any labels. Here this is called as the label or the target you are going to map. Like it could be a continuous value or a categorical value. That's supervised learning. When you go for unsupervised learning, you don't have any target. You have an unlabeled data like this. You have a bunch of data, you categorize them into groups. Something like these guys are similar, these guys are similar, these guys are similar, and so on. Then there is something known as reinforcement learning, which is done in games and all. We have a player, which is the computer. We have an environment, which is the gaming environment. It does any action, and if the action is good or correct, we give high reward. If the action is bad, we are going to reduce the reward. So over the time it iterates and do this action every time, and when it does great, we give high reward. So when it does one by one, over the time the model or this agent or this player tries to improve its performance. At one point of time, he understands which is the correct action and learns to play. So that is reinforcement learning. So in this, commonly we have this particular thing which is the features versus target. Features is going to be the categories you have in your data for mapping, and target is your prediction or the label. Something like here the target is cold or hot, here the target is the temperature, here the target is the shape, and the feature is going to be these things. Okay, so here the features may be something like the humidity, the temperature, or temperature is the prediction, right? The humidity, the rainfall level, the sun values and all. And you would be relating and finding. For example, this is a chart between your feature, which is rainfall, and the target is umbrellas sold. As you could see, we are fitting it in a linear regression straight line. When the rainfall increases, you could see the umbrellas sold also increases here. So if the rainfall is 150, you could directly plot it here and tell the prediction that the umbrella sold would be approximately 48, right? So that's how the predictions will be done. Okay, like statistics or pretty much basic maths we will be doing. Okay, so this is an example. This is univariate. You are using only one feature, but you have other features like this in machine learning. It could be car name, year, present price. You are going to predict the price of the car, which is the selling price. So you would be using other features like the age of the car. We know that the age of the car increases, the price will be decreasing, right? Because the recent cars will be having high price. The age is less. 1 year old car will be high price. Very old car will be, the price will be less. So like that we use other features to make prediction, and especially we do the same in deep learning, but instead of these some basic statistical model, we go with deep learning neural networks like this, and how these neural network actually works and make prediction, and that's what we will be discussing on day 4 on deep learning fundamentals. And from next session onwards, we use Jetson Nano as a device, and we won't be doing these demos and all. We'll be going and learning deep learning fundamentals. Then in Jetson Nano, in Ubuntu, in that Linux, we'll be installing TensorFlow, PyTorch. We create neural network, we train our model, we learn image processing. finally we move towards our final achievement, which is going to be that autonomous vehicle robot. Okay, so that was going to be the final tasks. Please follow the agenda and follow through the next sessions. Thank you all. Thanks for watching. We'll see you tomorrow. I hope you guys enjoyed the demo of the deep stream and NVIDIA VisionWorks and all, as well as the CUDA informations and the basics of machine learning. Tomorrow we start with deep learning basics. If you guys are familiar with machine learning, please just give a recap and come for the next session. Also, 2 days is left for this internship to end. If you guys are interested, you could still join. Just 2 days is left. You could join and get these benefits. You can convert the masterclass into certified internship on NVIDIA with AI. You'll be getting 30 days of recorded session, 30 days of PPT, 10 exclusive project codes, VIP community group for doubts and internship update, IETE confirmation letter, 90 days of access to our LMS course, assignments and tasks, weekly live sessions, resume building, mock tests, internship and participation certificate. All these things you could get it at a regular fee, which is 1,999, and the internship end on 20th. So we are giving a discounted fee at 999. The discount, it's a limited offer which will end on 20th. So if you guys are interested, you could use the link, register and get the benefits. The registration link has been posted in chat box. 2 days is left for this internship to end. If you guys are interested, register. You would be getting the all the Linux command files which I am doing, executing, documents, data sets, code files, downloadables for you to execute. Thank you all. Thank you.